Hello, everyone. Welcome. My name is Sid. I'm a Principal Solutions Architect here with AWS. And welcome to the Routing Loop, our weekly networking show where we talk about the greatest and the latest in the AWS networking space. And if you have been following us for the last few weeks, we have been talking about network observability. And I think today is the last session in this series. And we are going to end this by talking about something special. Network reachability and access. Now, if you think about network reachability and access, you want that for performance. You want to track availability, but also security and troubleshooting, right? So to talk about all of this and which AWS tools can help you, we have a special guest today, Ankit. So I'll hand it over to Ankit to introduce himself, who he is, what he does with AWS, and then to kick off the session.
Hey folks, I'm Ankit. Sid, can you hear me?
Yes.
Awesome.
All
Hey
good.
folks, I'm Ankit. I'm a networking specialist solutions architect here at AWS, and been at AWS about 4 years. And in my current role, I support what we call AWS industries customers, or what we call internally as global customers. So most of my customers have like large distributed global multi-region, multi-direct connect kind of ecosystem. And today we'll be talking about network reachability and access and analyzing the access as Sid mentioned. And that becomes very important when you have a large multi-account scenario where you may have multiple VPCs connected through constructs like transit gateway or VPC peering, etc.
Awesome. Yeah. So it's I think it's a very relevant topic because I work with enterprise customers as well, and I think almost every customer, and even like if there's startups, right, and the small business customers as well. Everyone's setting up multiple VPCs. Everyone has some kind of hybrid connectivity, and once you start scaling, as things from a troubleshooting standpoint, as like things go haywire, you want to know what's going wrong, where the issues are, and as well from a security standpoint, you want to control access. You want to have audit trail of what kind of network access my team has. So I think, yeah, it's a very relevant topic, and I think everyone listening in would be really excited to know what we have in that space from an offering standpoint.
Yeah, it's interesting you mentioned debugging. I started my career in support, so that's a topic that's very near and dear to heart, and excited to present it. Are we good to for me to share my screen and start the presentation,
Yeah,
sir?
let's jump into it. Yep.
Okay. All right. Let me know when you're able to see it.
Yep, all good. Let's go.
Awesome. So we are through with introductions. So, folks, when it comes to observability, right, before we go into the specific tools, I wanted to take a minute about some of the pillars of observability. So, we have detect, investigate, and remediate, right? So, if we talk about detection, this is where CloudWatch, dashboards, etc., come into the picture that show you a monitoring status of your deployment. Uh, you can set alerts based off of specific metrics, and then the most common one, you have your angry stakeholders who tell you that the network is perhaps not working, and even if it's something else that's broken. Then the second bucket is investigate, where you start diving in as to what's truly going on. What do my logs say? What do my cloud trail access trails say? And in the networking side of the house, we use utilities like ping and traceroute pretty often to even find out whether there is connectivity, which is where pings come into the picture, or use something like traceroute to find out where in the networking path something might be broken. The third bucket is remediate, where you actually take actions to restore services. So just to draw guardrails for, let's say, the next 50-ish minutes, we'll spend all of our time in the detect and investigate buckets today. And another major thing to keep in mind is today we'll be talking about AWS specific tools, as in your workloads are in AWS. I think last week said a product manager came in and spoke about hybrid debugging as well. So perhaps you can provide the link for that in case the audience is interested in more of on-prem to AWS debugging. Now, with that, the first tool that we're going to be talking about is VPC Reachability Analyzer, or short VPC RA. So it's a lot like Traceroute, but there is more to it. So at its heart, VPC RA is a config analysis tool. And I'll keep throwing out analogies or comparisons with Traceroute. So Traceroute is a data plane utility in that you start sending out ICMP probes with varying TTL values and see where it fails. Reachability Analyzer, on the other hand, does not operate in the data plane. It operates in the config plane. How it does that is you provide it with a source and a destination, a lot like Traceroute, and then it gives you a hop by hop analysis of the path, also like Traceroute. Now, these are the similarities. The differences are Traceroute fails at the first sign of a network blockage because it's in the data plane. Whereas Reachability Analyzer is a config analysis tool. So if let's say there are seven intermediate resources between a source and destination, RA analyzes the config of all of those intermediate hops and tell you what are the blockages. Since it's in the config plane, it has the capability to tell you that, hey, there is not just one blockage, there might be five blockages between the source and destination. So pretty powerful that way. And then thirdly, it supports multi-account deployments. So if you have a scenario where your application owners have their own VPCs, then your networking account deploys stuff like transit gateways and firewalls to connect those VPCs. You can always use a dedicated admin with Reachability Analyzer and say that, okay, I want to trace connectivity between source that's in account one and destination that is in account two. Now, let's look at a sample use case, which is exactly the same. You have VPC1 that has some workloads like EC2 instances in it, same with VPC2. And then you have a transit gateway that should provide connectivity. So this VPC could belong to one account, and this VPC2 could belong to another account. And when it comes to tracing the network connectivity, it's often the central network account that mostly cares for that. So with VPC Reachability Analyzer, when you want to use it in a multi-account scenario, you would want to use a delegated admin, which is most often going to be your central networking account. I'll pause there, folks, in case there are any questions.
Um, yeah, I don't see any questions at the moment, so I think we are good to continue.
Okay. So, net, consider Reachability Analyzer as your debugging friend. I personally call it Traceroute plus plus. So with this, let's head into Network Access Analyzer, which is NA2 for short, right? Now, in this one, I'll draw parallels or comparisons with Reachability Analyzer. So firstly, the similarity. NA2 is also a config analysis tool. Now, Reachability Analyzer was very laser focused. It would ask you for a source and a destination, and it would give you a network path analysis hop by hop. Whereas with Network Access Analyzer, you can discover all possible network accesses in your deployment, right? So in this case, there is still a concept of a source and destination, but you can say that, okay, the source is an internet gateway, any internet gateway, and the destination is a network interface, any network interface in any VPC. So you can discover all possible network accesses from an internet gateway to any VPC in your deployment. So that becomes very powerful in that if you have hundreds of VPCs in an account, you can immediately find out which VPCs have an ingress path from the internet. Another use case can be amongst all of my deployment within an account, which VPCs have an egress path out to the internet. So think of it as a broad brush stroke mechanism to find all network access paths. So let's see how this works. It has a few concepts that we need to grok. The first one is we create a scope, which is basically a container for your network access analyzer analysis. Then you provide conditions, right? You can create match conditions or you can create exclude conditions. Now, where these come into the picture is compliance related use cases. Let's say you have an east-west VPC to VPC access use case, and you mandate that there should be a firewall inserted for that VPC to VPC access pattern. So using network access analyzer, you can say that, okay, my source is a VPC, my destination is a VPC or network interface, and show me all the paths that exclude a network firewall. So basically, that would give you information about your unintended access. Then finally, you have findings that tell you whether there are any matching paths or not. So overall, uh, where I would recommend you would want to use network access analyzer is broad brushstroke style access analysis. And most of my customers use NA2 for unintended access discovery. So in the detection phase, if you would. Let's look at a sample use case. It's a um, um, pretty common example of a distributed ingress use case wherein you have a VPC. You have an internet gateway to accept traffic inside the VPC. And let's say you're hosting a public website that's running on these EC2 instances. And then you have a public application load balancer that acts as the entry point. So where would you use network access analyzer? Let's say you have multiple such VPCs deployed, uh, you know, uh, within your account. So you would say, tell me all of my VPCs that have an internet ingress or internet egress, and then you discover non-compliant network paths. So a very commonly deployed um, use case for NA2 is show me all of my VPCs that have internet ingress and show me all of my EC2 instances that are directly accessible from the internet or the internet gateway. So basically, show me all of my EC2 instances that might be dangling in public subnets for legacy use cases, for example, like Bastion hosts, etc. So from that perspective, NA2 can help you discover all those quote unquote non-compliant deployments in one shot. I'll again take a pause there in case there are any questions.
There aren't any questions, but I'm just curious, Ankit, when would I use NA2 from my overall life cycle? Like, let's say I already have my AWS account with my setup. Do I run network access analyzer every day, every month when I make changes? Like, how do I think about when I should be using this tool?
Yeah. So a very powerful way of using NA2 specifically, this tool is in continuous compliance check related use cases. So the frequency could be every day, could be every week, could be twice a day. And then you could use it to discover that, okay, I have a specific intent. For example, my intent is exactly what's on the screen, that my servers should be in private subnets. So this is your intent. And then you run it once a day, once a week, or twice a day to discover if this intent is invalid or whether your deployment is not compliant with this intent, right? So the continuous compliance is a very powerful use case for using NA2.
Got it. That makes a lot of sense. Yep.
Awesome. We are actually doing well on time, which means our demo could be pretty deep. So let's talk about when to use which reachability analyzer versus network access analyzer. So again, um, um, if you would take anything away from the theoretical part of this today's session, I would recommend snapshotting this slide. So RA, think of it as fine brush strokes. Why it's fine? Because it asks for a specific source and a destination, right? And use it to perform your debugging or verification, right? A common place to use it is, let's say you're onboarding a new account onto AWS, and you know what kind of connectivity that account wants, right? So you could use Reachability Analyzer to run pre/post maintenance window checks. That okay, you know what, Saturday 5 p.m. you were not onboarded, Saturday 9 p.m. you're onboarded, and here is a Reachability Analyzer check that shows that you have the right connectivity from your instances or your VPC to the list of 7, 8 destinations that you want to be connected to. Now, network access analyzer, again, broad brush strokes, right, allows you to discover unintended access across your deployment in an account all at once. So you would use it for stuff like continuous compliance verification use cases. That's it, and I just spoke about. And then you can use both of them together for your debugging and compliance related use cases, right? So let's look at a sample use case of that. So I'll go back to the same old deployment. You have a VPC that hosts public web servers through a public application load balancer, right? So first you define the intent. You say that my instances should be accessible, or the services that my instances are hosting should be accessible from the internet. Why? Because you want to provide services to the customers. Secondly, you want to say that users should not be able to directly use the internet gateway to get into my instances. In that, an ALB should always be present in the path, right? So how do you achieve this intent? Well, you create some kind of a loop that says use reachability analyzer to verify that when the source is an internet gateway and destination is specific instances, there is a path. Now it will give you the end-to-end path, but you would use RA to get a very laser focused yes or no answer. Is there a path or no? And then you would use a slightly advanced setting on network access analyzer to create match and exclude conditions, right? So you would say, oops, there's my cursor, that is there a path between internet gateway and the instances when ALBs are excluded, right? So it's kind of a negative use case, right? So when would you act on it? You would expect it always to be false. In that, in this deployment, there is no instance that the IGW can reach without going through the ALB first. So if a scope like this becomes true, that means that your alerts should fire off and you should take an action. That likely means that you have some kind of a bastion host or an EC2 instance with an elastic IP sitting in a public subnet somewhere, which is not in compliance with this intent. And this is a very commonly used scenario in enterprise with enterprise customers. I'll pause again, folks, in case there are questions.
Yeah, I don't see any questions, folks. If you this is your time to ask any questions, because we don't have a predefined determined script. After these slides, we're going to get into a demo. So let us know what you want to see, what any clarifying questions you have. But I just want to iterate, Ankit, what you said is, it's very important to define the intent. And I think it's not just important for what we're talking today, but where I'm seeing networking in general going is, especially now with like generative AI, which, by the way, if we have time, we may talk about how you can do some of this through Amazon Q and generative AI. Ankit has that teed up for us as well. But as you think about using agents to do some networking on your behalf, you explicitly calling out your intent is really important. And as we talk about some other services like Cloud WAN, which has policy based networking, having your intent clarified and converted into a policy which then can be deployed is becomes really powerful. So I'm seeing more and more of this in networking in general, where it becomes really important for you as a as a network architect or engineer to well document your intent, and then from there you can go and figure out how you can define some of these scopes and other policies and etc., depending on what you're using.
Yeah, that's a solid point, Sid. And I was thinking when you said as we dive into Gen AI and an agentic world, there are so many parallels also, right? Like an agent requires a definition and to carry out specific tasks. That's exactly what the intent is, right? So technically, you can roll all of this into a Gen AI slash agent kind of a wrapper, and that becomes your continuous compliance. That here's my intent. If it changes, I'll update that repo. But the actual tasks are still tactical that either a human can do, or an ISC framework can do, or an agent can do.
Yep.
Awesome. So with that, let's start looking at the demo. So let's do VPC reachability analyzer first, right? The use cases, oops. All right. The use case is still quite simple. You have two VPCs. So I'm using all of this in the same account, but the net point to remember is reachability analyzer you can use it across multiple accounts. So I have two VPCs, VPC1, VPC2. Each VPC has an instance inside of it in a private subnet. And then a transit gateway is supposed to provide connectivity to them, right? And the question is, can the instances communicate with each other in the first place? Now, there are two ways of going about it, right? One is you could get inside the CC2 instance and fire up a ping or a trace route, which will fail because we have added some synthetic failures. While trace route will tell you where it's facing, where it's failing, it won't be able to tell you whether there is one network blockage or five different network blockages, right? So with VPC RA, let's see how we can discover all of that in one go. So this is where we head out to the console. And of course, all right, I'm in the right account in the right region. Let's verify the VPCs first. So I have two VPC, VPC1, VPC2. This is the default VPC that I should never use because of obvious reasons. So um, let's take a look at our instances first. All right, so I have VPC1 instance and VPC2 instance. Uh, one is 10.2 and this one is 10.1, right? And again, the question is, can these instances talk to each other or not? So if I go back to this slide, it's a highly simplified version. But if you look at the places in network where you can enforce access restrictions or controls, right? There's security groups on this instance. There are network access control lists on that you can apply on the subnets. Then on the transit gateway, there are routing tables. So let's discover what each of these configuration elements look like without having to go into each each of those elements' page on the console. So for that, you would go into your network manager. And by the way, Network Manager is your one-stop shop for everything related to network management, observability, debugging, etc. So in the monitoring and troubleshooting section, you go to RA, Reachability Analyzer. You say create and analyze paths. So I'll say enter VPC path. So my source type in this case is a network interface, or actually I can use an instance directly. And the source is VPC1 instance. Is it real quick? Is the font all right on the screen?
Yeah, looks good to me. But folks, if this is small for you, if you're watching on a phone or something, let us know and we can increase it. But I think it's good for now.
Okay. So I'll keep rolling. The source is my VPC1 instance. My destination is my VPC2 instance. I mean, I won't worry about the protocol, but let's say TCP. And let's give it session pitch. By the way, I'm a big fan of using tags for any work that I do so that I can easily find out where my resources live. And in case you folks have any specific tag related strategy, please drop it in the comments. So it'll take a minute or so to complete. And uh, the net output that I would like to see is, firstly, give me a yes or no answer. Can these instances communicate with each other? And if not, what do I need to fix so that they can talk to each other? All right. So we see that these instances are not able to talk to each other. And this is the path detail, folks. This is actually very powerful. So it gives me a full hop by hop analysis of what's going on. This is my instance. Then what is the ENI, right? What is the security group, yada, yada, yada. Now, eventually, there has to be something that's failing, right? And check this out. So it calls out which element in the path is blocking this communication. So in this case, it turns out that the network interface that is attached to the EC2 instance in VPC2, it doesn't have any rules that allows this communication. And it specifically calls this out. Oops, right here. So none of the rules apply. Let's take a look at the security group config. So it's just a self-referencing security group, and we are going to need to allow that traffic to come in from VPC1 for this to work. So let's just use all TCP. Let's give the prefix of VPC1 and save rules. All right. Now, this is where, folks, your pre and post maintenance window or account onboarding checks also come into the picture. So once you create a path, right, you know that my previous analysis said it's not reachable. You can rerun the same analysis, right? And we don't need anything to change. Like we didn't add anything on the networking layer, so we don't need to add any filters to it. You just confirm it, and this kind of becomes your repository for understanding what was my reachability before and after, for example, a maintenance window.
So why we have while oh well, it was quick. The good thing is it was really quick.
Yeah, yeah.
uh, but before you jump into that, a quick question we have from Tech Fueled, who is watching live from Twitch. Does this work in a cross account setup?
Yes. So for reachability analyzer, your source and your destination between which you want to trace the path can be in different accounts. The key factor to keep in mind is you're going to need delegated admin capabilities so that the account that fires off the reachability analyzer analysis, it has the necessary permissions to look into the security groups or the network access control list or the routing tables, etc. So net, yes, works in multi-account scenario and requires a delegated admin permission. Awesome. So now that we run this analysis the next time, we see that it is reachable, right? And again, like I was saying, this ends up becoming your repository for understanding what was my network state or the operational state before and after a maintenance window, for example, when it doesn't even need to be maintenance window, could be any change, or again, you could incorporate this in your continuous compliance checks or reachability checks to make sure that connectivity between your critical components is always available. And if not, you can fire off an alert based off of this. All right, folks, what questions do you have on Reachability Analyzer before we head into the demo for Network Access Analyzer? And I'll bring up the screen where you can see the high-level points of Reachability Analyzer.
Yeah, so I see a question from Red Eye Developers streaming live, who's watching us from YouTube. Just, I think he wants to confirm analyzer is just for debugging the communication, right?
That is correct. Debugging or verification. Like on a good day, you would use it to get a green answer. On a bad day, you would use it to understand why are you getting a red answer.
Awesome.
Okie dokie. So that takes us into the demo for Network Access Analyzer. And again, folks, just to ground ourselves, Network Access Analyzer, broad brush style methodology to discover unintended access. So I'll take you back to the web app use case. You have users on the web who hit an application load balancer that is public. The targets for this application load balancer are private instances that are, let's say, your web servers. So the question you want to ask is, are there any instances accessible from the internet without an ALB in the path, right? Which means that really you're asking, are there any public EC2 instances dangling in your deployment? And secondly, you want to run a probe like this across all the VPCs in your account. So if your account has, let's say, 50 VPCs, instead of using something like Reachability Analyzer and running 50 probes that are specific sources and destinations, can you use a broad brush methodology to create like a sweeping probe across your deployment? And that's where Network Access Analyzer comes into the picture. So for that, we're going to go back to Network Manager. And this time in Security and Governance, you will see Network Access Analyzer. So, oh, I thought I deleted these. I need to do a better cleanup job. So these are from, I think, yesterday when I was testing all this. Yeah, September 2nd. So folks, if you focus on these four that are at the bottom, these are created by Amazon, right? These come with your AWS account. And these are some of the most common questions that customers use to ask access related questions on Network Access Analyzer. So for our use case, we want to discover internet-based ingress access, right? So we will use that. We will see what is AWS all internet gateway ingress. We will take a look at this one and let's see what the definition says. So it says match all sources that are internet gateways. Again, keeping in mind an internet ingress specific use case. So the source is any internet gateway and the destination is any network interface in any of my VPCs, right? So this is powerful. Again, a broad brush sweeping style motion. So let's run this first and let's see what all we get here. And while this is running, we will also create a brand new analysis. So you would say create network access scope, and we want to say, let's say validate access from trusted networks, right? Wherein you say discover non-compliant ingress paths. So in this case, your source is a source type that is all internet gateways across your deployment in your account, and your destination, we will say, is all network interfaces. Technically, I could use EC2 instances as well, but network interfaces is more broad because sometimes you might use like serverless deployments, etc., where you technically don't get an EC2 instance. All you get is a network interface. And this time around, I'm going to add an exclusion condition as well. So going back to our use case, we want to discover if there are any EC2 instances accessible from the web that bypass a load balancer. So we will say exclude resource type of load balancers. Where are they? I think I'm in the wrong section here. Let's go back. Create, I'll say empty template this time around. Discover non-client resources. So I'm going to match stuff from internet gateways. Destination remains network interfaces, and add an exclusion condition through. There you go. So I want to make sure that I'm excluding everything that comes in through an elastic load balancer. So again, it's a negative use case because you're discovering unintended access. Create network access scope. And let's analyze this. And this takes a minute or a couple of minutes to run. And in the meantime, we are gonna look at the scope that we fired off earlier. So this is the one that we fired off like a few minutes back, and it has findings. So folks, in the network access analyzer world, you get findings instead of a simple yes, no answer. So what you found is that in VPC 1, there is an internet gateway that has direct access to a public instance that is deployed in VPC 1 as well. So, and it's accepting connections on TCP port 443. Now, if we go back to the deployment, we actually had two VPCs. So it looks like, so with this network access analyzer, you were able to create a broad brush stroke style discovery of finding out non-compliant resources across all of your VPCs in the account. So it becomes pretty powerful that way. Any questions on this one, folks, before we start diving into the more granular um, analysis that we just fired off?
Yeah, I'm not seeing any questions in chat yet. So I think we should continue. But folks, yeah, if you, I know this is like we're diving a little deeper into the console, so not everything might be crystal clear. So yeah, let us know if you want us to like slow down or talk about something different.
And folks, that's a good point too. We guys see this console uh, literally every day. So in case you have any specific questions on, hey, what does that button do? Please fire them. All right. So this is the second more deeper probe that we fired off, right? And in this case, what we said is that when the source is an internet gateway and the destination is a network interface in any of my VPCs, and traffic does not go through a load balancer, are there any such deployments? Because that's non-compliant for my intent. So in this case, again, it says there is a finding, right? And the finding is that same public instance. And if we look at the details of this public instance, right, what what you would find is that this instance firstly has a public IPv4 address, right? So it has an elastic IP address associated with it. And then secondly, on the networking side of the house, looks like this is deployed in a public subnet. So net, going back to our deployment that wants my intent always to be like this, it seems like I have a public EC2 instance dangling somewhere in a public subnet, which is non-compliant. Now, using RA2, you can discover such non-compliant resources in any number of VPCs that you have in your account. So to fix this, you can simply delete this EC2 instance and then fire off the same scope. So let's fix this. These are my EC2 instances. So if I go to VPC1 public instance and let's say terminate the instance and give it a few minutes. Okay, there you go. So now this is the continuous compliance use case, like Sid was mentioning earlier. You can run it every 6 hours, every day or something, or you could, take immediate actions as soon as you find a finding, a non-compliant resource. So in this case, you found a non-compliant resource, right? Just like access analyzer, sorry, just like VPC reachability analyzer, you can rerun your um, analysis. So you would analyze the same analysis again, you would fire it off again after taking the remediation action. And let's see if it still finds any findings. If it does, we will fix those two until we get a green answer. So this is a continuous compliance related workflow. You, you know, you run it, you always expect zero non-compliant resources. When you get a finding, you fix it, you rerun it. If it's zero, you are good. If it's non-zero, you continue the loop. So that's a very real world way of using these tools for your network observability and security and compliance. All right. This was actually faster than I uh, experienced yesterday. So fantastic. So this time, after fixing or closing out that EC2 instance, terminating it, this time I don't have any findings. So from a security admin or a network admin, their dashboard's perspective, after taking the remediation action, your deployment is in compliance again. So this is how you would use tools like Reachability Analyzer and Network Access Analyzer for your networking deployment. Now, folks, in case there are no questions, I guess we have enough time to provide a wee little Amazon Q flavor on it and see how you can use like network language processing for discovering such findings in the first place. Shall we do that, Sid?
Yeah, I think that's exciting. I've not seen that yet, so I'm excited to see that as well. We don't have any questions, but I do see there's a comment from Higrings, watching live from Twitch, says looks pretty good. The demo helped me to clarify the functionality. Thanks. So it looks like it's resonating with our viewers, and the demo is helping out. So uh, let's uh, let's continue, Ankit. And I think the Gen AI piece would be really helpful to see as well.
Yep, let's do it. And hi, Rings, thanks for the feedback. Folks, if you have any questions around some of the monitoring and reachability or connectivity related challenges that you may have seen in your deployments, please fire them too, and we can have a discussion on, how you could best solve them. And if it's not possible, that would be good feedback for us to go and improve our platform. So with that, let's go back to the queue related uh, lifestyle or workflows that you can handle. So, do you see my console window? Sorry, the terminal window.
I do see terminal, yes.
Awesome. So, folks, where I'm at right now is I'm in QCLI, and all that I've provided it is, or this terminal is my AWS credentials. So I'm tied to the same account. And this time around, instead of going through the console, I'll use this natural language interface to discover the state of my network, right? So I can start off with finding something very simple like, do I have any instances? Do I have any EC2 instances in my VPCs? Check VPC1 and VPC2. So technically, you don't need to say check VPC1 and VPC2, just that this is my demo account and I have other VPCs as well. So I just want to keep the scope specific for this deployment. So firstly, let's find out what's the state, and then let's ask it to discover very specific information around, whether there is connectivity or not.
Ankit, maybe let's make this a little bigger. Yeah, I think that's much better. Yep.
All right. Okay, so I got an instance in VPC1. This is the same instance that we saw earlier. It's in instance subnet 1. This is my private subnet. Then I have VPC2. There is an instance there. And then there is an instance over there as well, right? So if we think about our VPC to VPC use case, or the network reachability analyzer use case that we saw, wherein we ask a question, can the instances communicate with each other? Earlier, we went on the console, we performed some click ops to find a yes or no answer to this. So let's try to discover the same from Amazon Q. Can my EC2 instances in VPC1 and VPC2 communicate with each other? Use VPC reachability analyzer to find this answer. And there you go. So, folks, while it's thinking, right, I guess it behooves us to talk about a couple of uh, observations from using agents like Q, right? As you know, nothing is perfect, and sometimes the answers could be misleading, right? So technically, you could leave your answer right here. Can my EC2 instances in VPC1 and VPC2 communicate with each other? in which case it's going to find out the answer to the best of its capability. But using a specific prompt like this would inform it to, go into VPC reachability analyzer and create a new analysis or create a new path, and then highlight the information based off of that. So I was calling this out because yesterday, as I was testing this out, I was giving it only the front part of the prompt, and the accuracy was, I mean, I had to double check the accuracy. But with RA specific prompt, I know that it's going to use the best tool for the job and give the answer based off of that. All right. So net net, it says that yes, there is a networking path. It is true. And it again gives the entire path as well, right? It looks into um, the route table. It says that traffic is going to the transit gateway, right? Transit gateway has the necessary routes, looks at the security group, and then gives a yes or no answer. So it becomes very, very powerful that way. Um, any questions, folks?
I don't see anything come through yet. But for folks who are not uh, aware of this tool, I think it might be just good to just give you a recap of what Amazon Q is. So Amazon Q is our generative AI assistant, which is which helps you with multiple use cases. Here, what we are running specifically is the QCLI. It's integrated into the CLI, and here you can perform a bunch of actions. Now Q is powered. I think it's currently powered by Anthropic Claude, although you can pick and choose your model. Behind the scenes, it's using Anthropic Claude 4, the latest model from Anthropic, to power its thinking and reasoning. And if you're using the QCLI, it's provided a bunch of tools which it can use by default. So when Ankit is basically asking it to go into its VPC and tell what EC2 instances he has, it's using an AWS CLI tool, right? So there's an AWS CLI which you can use to make API calls about your account. Q has direct access to it and all the description behind it. So what Q is doing behind the scenes, it's understanding when Ankit is saying use VPC Reachability Analyzer, it's going into its tool list, seeing, hey, I have access to AWS CLI tool. I know exactly what API to call to access VPC Reachability Analyzer, and then making that query, right? So that's why all of this is happening, because Q as an assistant has access to AWS CLI. Now, if you are working in the in the generative AI world, you probably know what tools are, and you can provide additional tools access to Q through MCP, MCP server. And we have a bunch of tools which are AWS native, as well as community tools which you can provide access to Q as well, if you have any other use cases. But that's pretty much sort of what we are working with here, and how this is what you see in the demo today. I do see a question here. I think it's related to Amazon Q. Ankit, I'll let you answer this one. How was Amazon Q able to access your account in Q Chat? How did you provide access credentials for this particular session? Because I think you didn't share that, but it'll be good for folks to know how you did that.
Yeah, yeah. It actually piggybacks off of what you were talking about with AWS CLI. So for this terminal, folks, I basically created a role for CLI access, and then I provided the access credentials within this terminal for my AWS CLI commands. So TechFuel, uh, to give you a specific answer, yes, I provided the programmatic creds or my access key ID and the key within the terminal, and Q is piggybacking off of that. Now, one of the things that I got a chuckle out of last night was actually using Q to break the deployment and then using queue to discover the breakage. Shall we do that in case there are no more questions?
Yep,
Okay.
sounds good.
So let's do this, folks. Let's go back to our deployment. So again, two VPCs connected by a transit gateway. Uh, let's break the security group out here on the VPC2 instance, make it very restrictive using queue, right? And then let's discover the breakage using queue, right? So kind of a um, um, functionality testing and discovery and remediation all using a queue or an agent. So let's see what is the security group on instance in VPC2. Show me the rules. And folks, in case you all have discovered any new innovative ways of working with these Gen AI based tools, please let us know. It's one of those things where we all learn from each other. So check this out. This is the rule that's allowing communication from VPC1 into VPC2. So let's use queue without using any security group IDs or anything. Let's just use natural language to remove this rule. So I'll say remove the rule. Let's say security group rule. So there is no ambiguity. On instance in VPC2 that allows communication from VPC1. So in this step, we are breaking the connectivity using queue. Then we will detect that using queue, and I even want to fix it using queue. All right. So VPC2 security group removed TCP port, all TCP ports from 10.1, which is VPC1's CIDR. So let's go back and say, can my EC2 instances in VPC1 and VPC2 communicate with each other? This time, the answer should be no. When it takes longer than expected on a live demo, it makes me a little nervous. Okay, there you go. All right. So the demo gods were nice this time. So there is no network path. And again, we used queue to break it. We used queue to detect it. Now let's see if it can fix this for us. Can you fix this connectivity issue between VPC1 and VPC2 by Okay, so can you fix this connectivity issue? And again, I'm being a little conscious about not providing any resource IDs, which again abstracts out the actual, heavy lift that you would need to do. So just talking in the context of VPC1, VPC2, not providing any resource IDs, not providing any IP addresses, etc. There you go. So it's updated the security group and restored the changes. I mean, we could have said just undo the changes, but that wouldn't be as interesting. Now, let's ask the same question again. Can my instances communicate with each other and use RA to find this answer?
So Ankit, while you're running that, um, we just have 5 minutes left, and I would say we have more like 2-3 minutes left. We do have one quick question from Venkatesh. I'll bring that up. I'll summarize the question. It basically is, what's the difference between network access analyzer and inspector? Because Amazon Inspector also has a network reachability check, which it can do. Are they redundant? Are they complement? Do they complement each other?
Yeah, that's an interesting one, and you caught me. I'm not very well versed with inspectors, so perhaps I'll need to
So
do some research on that.
yeah, I'll probably share what I know, and then we can always follow up. So from what I understand, inspector is something which is specific to EC2 instances, and the network reachability is tied to like the instance, right? So um, inspector gives you a view. The world is centered around an EC2 instance. So what kind of vulnerabilities do my EC2 instance has? What is the network reachability of my EC2 instance, et cetera, et cetera, right? So versus, as you mentioned, Ankit, network access analyzer has a broad stroke, right? So it's more about that compliance high level view saying, hey, what in my accounts or in my VPCs has network access, which is not my intention. So it's a broad brush versus network versus inspector gives you a very specific view around a specific EC2 instance. So I would say they're complementary in that sense and don't necessarily overlap from a functionality standpoint, although there is that very small overlap where, for any particular EC2 instance, you get that's same information, but from a different perspective.
Awesome. That's something new that I also learned, Sid. I know we got to run, but just to complete the thought. So net over here, we used Q to uh, verify connectivity. The answer was green. We broke it. We saw the answer was red. Then we fixed it, and then the answer is green, right? So all without using any security, any resource IDs, etc. So I would say explore using tools like these in your day-to-day workflow. And uh, since we are at time, I would say if there is anything that you folks would take back from today, it is this slide. Please take a snapshot if you need to, which calls out when you would use each of these features in your deployment. And with that, back to you, Sid.
Awesome. I'm just looking if there's any other questions. Tech Fueled, it does. Net Inspector also has a network reachability aspect to it. It's not just for vulnerability assessment. But as I said, it's very specific to an EC2 instance where this inspector runs. Um, I don't see any other questions, and we are just 2 minutes out. So, Ankit, thanks again for taking the time and sharing about network reachability analyzer as well as access analyzer and giving us this awesome demo. Folks, we will be back next Thursday. I don't have exactly what we're talking about next week, but I did share the routing loop URL where you can go and check out what's coming up next. And stay tuned for more awesome sessions like this. See you next week. Thanks, everyone.
Thanks, everyone.